So hi, I'm Vicky Steeves. I'm the librarian for Research Data Management and Reproducibility at NYU. I'm half-time in the library, half-time in the Center for Data Science. So I spend a lot of my time teaching all these things I'm about to teach you. So that's pretty good. I hope to make the materials go in an order that I thought would be consistent for kind of how you would work in a project. So maybe if I turn down my brightness, the contrast will be better. Is that a little better? The contrast? Okay. So we're going to start with version control generally and GitHub, Git Lab more specifically. So basically setting us up for success by understanding what version control is so we can implement it throughout the whole of our project. We're then going to switch to OpenRefine for data cleaning, which is typically the first thing you'll do in a project as well. Then we're going to go into some literate programming techniques. So literate programming, we're going to interweave code and narration to tell a story, to comment our code better, to force us to anyway. So we're going to do that with R, Jupyter Notebooks. I'm going to touch on ReproZip and VizTrails, which are two kind of, ReproZip is about creating self-contained, fully reproducible packages. So at the end of your project, you want something to share with a publication. You have all the stuff in GitHub Git Lab. You make this little compendia, your good little addition. Then I'm ending with this thing called the Open Science Framework. So that is for project management. You can use it at the very beginning of a project or at the end to publish. And I'm going to go over, so I'm hopefully going to take you through the whole life cycle. Can't be a librarian without saying life cycle 1,000 times. Librarians in the room get it. And on the corner. Great. So maybe just briefly we can go around the room, just say your name and your discipline, just so I can put a name to a face, and then we'll get started with version control. Can you start?
I'm Michael, and I'm double majoring in math and philosophy.
Great, welcome.
I'm Ray Humor. I'm the director of the master's program at the Guidance School.
Great.
I'm Valentin Danche from U Chicago. I'm sociologist.
Awesome.
I also work with biomedical diagrams.
Great.
Hi, my name is Marisa. I'm from the University of Michigan, and I'm in the Health Sciences Library. I run our research in humanities.
Great.
I'm Madison. I'm majoring in philosophy. Haven't decided if I'm going to double major or not, and then going into law.
Great. Well,
Derek, DNA sequencing and genomics.
thank you.
John Barbuto, neurology.
We'll go over that.
I'm Anna Nietrauer. I'm the Digital Initiatives Librarian here at the University of Utah.
And thanks for tweeting at me.
Oh, yeah.
Everybody tweeted me if you want, or a Mastodon, if that's your thing.
I'm Rachel Whitman, and I am the Digital Curation Librarian.
Great. OpenRefine's going to be really useful for you.
I'm Lizzie Calloway, and I'm the Digital Humanities.
Great.
I'm Mary at Eccles Library.
Great.
Joe Tillman, critical care at the hospital.
Hospital, okay.
I'm Jessica Brennan, I'm ABF vestibular at
Oh, great, welcome.
Jared Nisler, I'm a student of Library Information Science.
Oh yeah, welcome to the field. Sorry, I'll give a little bit extra props. Can you shut the door as well? Sorry. And in the back, last but not least. Great, welcome. Okay, great. So let's get started with version control. So broadly speaking, version control is basically the management of changes to a doc. So for practical terms, it's the way that we restore, compare, and manage changes to a bunch of our stuff. So this is the infamous PhD comics, which goes over why version control is important. You start out with your final paper that just got accepted, but then you have reviewers' comments you have to integrate, and then another set of reviewers' comments, and it spirals until why did I even come to grad school? So this is the situation that we are trying to avoid by using version control. So we don't want to have to rename different versions of a file. We just want to have one copy that we can go back and look at the different changes. So using version control makes it easy for us to get a broad overview and a very granular overview of changes to your files. And I say files more broadly because people think, oh, it's Git and GitHub, it's Git Lab. I can only use it for code. But no, you can use it for any plain text file. That includes a CSV, a TSV, JSON, YAML, MARC, whatever sort of static plain files you have. It does not apply to things like docs, Microsoft Docs. So anything that is in a fancy wrapper, anything that you need a specific binary to open, cannot be tracked by Git, or generally tracked by version control software. So the most important factors in version control, the things that we make it that we really like it for, the first is obviously versioning. So you want to have a log of files without that renaming problem, and you want to be able to collaborate. So it allows us to come in. Okay, sorry. So when we work with collaborators, a big part of the work we do involves merging changes from a lot of different peoples, looking at a lot of different perspectives, collaborating on the same set of files. So in Google Docs, we see this in the suggestion feature, where a lot of people collaborate. So this provides us a way for merging changes across a broader set of project files. Versioning also lets us roll back. So if someone deletes your dissertation and you have it saved, you can just go back. It also is really good for provenance, for understanding. So if my postdoc wrote some code 5 years ago and I have questions about it, I know who to ask, rather than, oh, who wrote that code 5 years ago? And backup. So while versioning and things like GitHub and Git Lab are not supposed to be your only backup, it is a good way to store things on multiple computers, which is better than the alternative. So it also is pretty good for just making sure we have a copy of our stuff somewhere central as well as on our computer. Okay, does that jive with everyone? Great. So Git is one of the most widely used systems for version control. It's free, it's open source. Does anyone know the origin story of Git? I will. So the origin story of Git, basically Linus, the guy who, does anyone know what he made besides Git? Linux? Okay, yes, he made Linux. So he hated the existing revision control systems. He thought they were clunky, and Linus is kind of a curmudgeon, so instead of sticking it out, he just wrote his own, and it ended up being kind of great. So it got wide adoption. People were emailing Git repositories back and forth to each other during the development of Linux. So it can be used on your local computer, it can be put on a server, and it's used broadly. It manages a project called a Git repository. So we've heard this with GitHub repository, Git Lab repository. They borrowed it from the original kind of glossary that Linus came up with. So it's most powerfully employed when we're doing collaborations. And basically, a Git repository contains snapshots of your files. So at any given point in time, I'm going to say, OK, this is the new version of my files. That's a snapshot. And then it has references to those snapshots. So it's as if we have, here's our snapshot. We have some files. We'll call it A. We have another one called B. And if I ever want to go back, I now have a reference to that first snapshot. So you have a snapshot and a reference, so you can always go back and forth between different versions of your files. So the Git repository is a hidden folder. So typically, when you download a Git repository, you won't actually see it. I can show you a quick example of that. Here's the materials for class. If I hit Control-H, you'll see this .git. This is where Git stores all of its information. Don't ever touch this, delete it, do anything. That would be catastrophic. Just know it exists. That's all I'm asking. So basically, once you have Git on your computer, you interact with it through the terminal. So the command line on Windows, the terminal on Mac and Linux. And again, you can only have plain text files, CSV, Python, R files, JSON, etc. So Git works on these things called branches. We're not going to go into branches, but just know, unfortunately, computer science needs some more philosophers. So everything starts on branch master, which is terrible terminology, but it has not changed yet. So by default, everything's on a master branch, and you can have different branches if you want to add new features. But again, we're not going to that. So basically, in your Git project, there are 3 states of being. So the first is just you're working normally. You have some text, maybe a Readme file, some R scripts, a CSV that contains your data. And so you're just working normally. You haven't tracked any changes yet. When you want to tell Git, hey, there are some changes made to the project, this could potentially be the new version of my files, you add it to the staging area, literally with the command git add, which we'll go over later. So, but the idea is you take it from completely Git has no idea it exists to Git is aware of its existence. And then when everything is great and you want to save the new versions of the files, you commit to them and they become the latest version in the repository. Does this make sense? So there are 3 states of being for your files. Completely, Git doesn't know they exist. Git knows they exist. Git puts them as the newest version.
Why do you need a staging area?
Because you want control over what becomes the latest version of a file. So for instance, in our script, or in an R Markdown file, you have a code chunk, some text, and a code chunk. If you only want to commit one of the code chunks but not the others because it's not ready, you can do that in the staging area. So it gives you really granular control over what becomes a new version. Does that make sense?
So you say like you would then save part of the file.
You can get very granular, and that's kind of the point, because otherwise you would say git add a or git add period, which adds everything in the repository, which is maybe not what we want to do. So for instance, you'll notice in my outline here, I only have these different R Markdown files, but in my actual repository on my computer, I have the rest of the week. So I chose not to commit them, and I chose not for you to see them, because it was my choice, and Git lets me do it. So the staging area is there specifically to give you very fine-grained control.
When it moves to a repository, can others see it and work on it?
If you choose to push to something on GitHub or Git Lab. So in this case, I'm building a website from Git Lab. So when I pushed it, the changes that are in the staging area that were committed were reflected online. But we're going to go over that later on. So don't worry if it sounds too complicated now.
So I know this is pretty detailed. So in your project folder, you have the whole week, and then in your staging area, you've got the different days.
And then I chose to commit to them. So I committed today and part of tomorrow. And then I reflected those changes on GitLab by pushing. And so that's why when you scroll over, you only see this and not the full week's materials.
So like for instance, say I have a text file.
Sure.
2 paragraphs.
Mm-hmm.
And I put that text file in the staging area.
Sure.
You can then commit just the first paragraph.
Yep.
It would create then a new text file.
Nope. Same text file.
But it would just show you the first paragraph?
Yep.
Whereas
And then when you decide to add the second paragraph to the staging area, you can use git diff to see what's changed, and it will say you added a second paragraph. Does that make sense? Yeah. Okay. So that's the point of the staging area, to give you control. Is that concept okay with everybody? Okay. Okay, so basically as you work, this is the workflow. You have 2 commands to work with, git add and git commit, and it takes things through the different stages of Git. We're also going to look at how to do this in RStudio, because RStudio actually gives you some nice commands to do Git right from the GUI, so you don't always have to be on the terminal, which I know can be a big block for some folks. So also, I just wanted to briefly go over some good project management, because I am a data management librarian, and when you create a new project, which is something we'll be doing, I would like you to do it with some good best practices in mind. So a good way to organize your project is, of course, I'm sure everyone does this, every project has its own directory. You want to put all of the text documents associated in a folder, perhaps called docs. You want to have all your raw data and raw metadata, so uncleaned, unchecked, in something called data. And this is going to be read-only. You are not going to change the files you put into the data folder. Does anybody know why? Yeah. So any files that you process, that you analyze, if you subset your data, you just put that right in a results folder. This way you always have the raw data to come back to. And then the source folder is basically for any code or scripts you might have. So a lot of these are variable. There's actually an R package to automatically generate this file structure for you, which we will look at in the R lesson. But for today, we are just going to keep this in mind as we work in our new projects. And again, the last little bit, please don't put any special characters in your file names like $signs, exclamation points. Don't use spaces, because we're going to be doing some things on the terminal, and you have to escape every space on the terminal. And that's really annoying, so just don't do that to yourself and others. All right, so I'm actually switching up the way that I teach this lesson. So typically, I have you use Git on your own computer and then push changes to Git Lab or GitHub. But today I'm going to work backwards. So we're going to start on Git Lab, and then we are going to do things locally after that. So does anybody know anything about Git Lab or GitHub? Just shout out. What do you know about it?
GitHub a little bit.
What is it?
It is a place where you can stick your Git stuff.
Mm-hmm. Yes, that's it. And you? Same thing? Sure. It's pretty much what I wrote. So basically, this is a table of the 4 most popular places that people host code, host specifically Git repositories, although GitLab can host Mercurial, SVN, and some other old-fashioned revision control systems. So I put some good criteria up here that I think is useful. So GitHub, everyone knows, was recently acquired by Microsoft. Or you should know they were just recently acquired by Microsoft. They were established in 2008. They do not use free software when they are coding their platform. They are not open source. You have to pay for private repositories, but it is ad-free. Whereas something like Git Lab, which is what we're going to be using today, is managed by it themselves. It was established in 2011. They use free software when they're writing their code. And in fact, the platform itself is open source, so you get lots of new features every month. It's pretty nice. And you can install it on your own. So for instance, in a hospital, you need to have strict control over your data, your code, so you can install GitLab on your own server. You have free everything, private repositories, large file hosting, free everything, and it's ad-free. The other 2 are a bit older school, Bitbucket and SourceForge. Bitbucket is from Atlassian. They also do have Jira. So they have some other sort of management platforms. And a lot of these follow the same. SourceForge actually can't have any private repositories. So if you're very committed to being open with your work, you could try SourceForge. So I thought it would be useful to see how people are using GitHub and GitLab to give us a good idea about what's out there, about what's on it. So the first, open data. So actually the US congressional data set is hosted on GitLab. At NYU, we have a health science library data catalog. All of the metadata and data is hosted on GitHub. And I found this really weird thing on GitLab I thought was funny. There's an open data set for memorial benches. So like when a bench in a park is dedicated to somebody, you can go check out that data set if that interests you. You can plot it. Folks use this for dissertation writing. So we had some few folks in math and computer science. So you must be using LaTeX, which is a programming language for writing papers. I have feelings about it. But anyway, people version their dissertations on GitLab and GitHub. So it's another way that as you're writing, you can track the changes to your dissertation over time and make it available for other people. You can use it to make a website, like I have made a website using GitLab here. Then there are just other randomly interesting things, like there's a package to check if a number is equal to 13. Somebody made that and just put it on GitHub. So people use it for lots of different purposes, not just simply, I'm going to write some code and put it up there. Sometimes it's, I want to share my metadata, or I want to share my dissertation, or I think this data set's interesting for other people. So there's a lot of different ways that you can leverage Git and GitLab. So I already walked through some of this, just telling you what GitLab is, what GitHub is. The great thing about both of these tools is they integrate into the Open Science Framework, which we'll be using later. So all of these tools interconnect in very good ways. So I've talked enough. Let's get everybody set up. So the first thing we need to do is to sign into GitLab. And the cool thing is you don't have to register for GitLab. You can sign in with Google, Twitter, GitHub, or Bitbucket actually. So if I asked you to make a GitHub account, so if you want, you can just go ahead and click sign in with GitHub, and that's going to be the way to go. I'll give you 5 minutes to make an account if you need to and sign in. Which is
GitHub or GitLab?
GitLab.
Make an account?
You can make an account here on GitHub and then sign in. But we're going to be using GitLab for the session. Okay. I have 2-factor on mine. And then just give me a little wave if you are all signed into GitLab with your hands so I can see you visually. Okay, thank you. This is going to be a good test of the Wi-Fi. Okay. So one point that I didn't make about GitHub and GitLab is if you are using GitLab and somebody is using GitHub, you can still work together because GitLab has automatic mirroring. So you can automatically sync between a repository in GitLab and a repository in GitHub. So actually all of my repositories are on both platforms. GitHub for discovery, and GitLab because I think it's a better product, and I use it every day. So you can actually collaborate between the both of them, which is pretty cool.
Why did you have a GitHub account?
Because we're going to be using it later on as authentication to other things, and because it's useful to have when you want to mirror things between GitLab and GitHub, which is something that people want to use. Okay. Are you good?
Yeah.
Okay, you're good? Okay, front row, you good? Okay. You guys in the back, did you, you're good? Okay, and for you guys, these are the materials. So these like things I'm using, if you didn't get it before. You need partner. Okay, you guys are all set? Okay, you guys getting there? Okay.
I just have to confirm my email.
Sure. Yeah.
Could you go back to the URL of your
Yep.
Git stuff?
So this is going to be for everything. So when you come to this page, you're going to see materials for not just the version control stuff, but for the whole weeks. So you should bookmark it for our week. Okay. Are you good? Okay, sorry.
I'm getting a not found, which probably maybe just type it down.
Vicky Steeves at gitlab.io. Here, just try that. Utah. Did you have the 2 U's?
Yeah.
Oh, you spelled Vicky wrong. V-I-C-K-Y.
Oh, okay. Yep.
Okay. Okay. So we're starting on GitLab, and we're working backwards to our own computer. So the first thing we're going to do is we're going to create a repository. So see this little plus button? You can create a new project, a group, or a snippet. So we're going to create a new project. And you can get this. So one thing I like about GitLab that GitHub doesn't have is it has better controls. So for instance, I could make this private, which is completely private to me and my collaborators. Can make it internal, so anyone who's logged into GitLab can see it, or public, which is just completely public. I'm going to do that, and I'm going to call it Utah Project, and boom. So everyone should be doing this. This should not just be me.
So we're going to
GitLab.com, and plus make a new project. I would recommend making it public, yeah.
Vicky, it was private.
I did it public because we're not going to be doing anything under wraps in this class. So
So we're getting messages about adding a SSH key.
you don't have to do that for now. Yeah. So you can change to HTTPS here, and then you don't need to configure an SSH key.
Where did you get that? Sorry.
So this is just the repository. So I hit new repository, and it brought me right here. So everyone should have something that looks similar to this. Making it public. We're gonna start open and finish open. Actually, maybe I can take this brief detour. A colleague of mine wrote a paper open from start to finish. Like he put his brainstorming notes in a Git repository, tracked all the changes from his like notes to the final version of a paper. And he's in astrophysics, and he used this algorithm, and the guy who wrote the algorithm opened an issue on his paper at like the beginning stages of the project to offer guidance. So it was a very good example of how working open start to finish can actually yield pretty good results. I haven't done it yet either. I'm working my way up, mainly because I leave embarrassing notes in the commit in the history. All right, so you should just have a blank repository.
Yes.
Okay, great. Okay, so now we're going to add our partners as collaborators. So everyone should have a partner. It would be better to be pairs. And you guys in the back, too, there's 3 of you. Okay. You're not going to be partners, because I won't have a partner. Does that sound good? All right. Okay, so to add somebody as a collaborator, you should see this sidebar. You scroll down to settings, and you click members. Everyone see the members? You click this, and then you need to get their username. What's your username?
I don't know. I made this account a while ago.
Where's it?
Scapegoat 1.
Okay, sorry, I'm trying to help him. He's having issues
Okay.
getting working still.
Scapegoat 1.
Do we have to add each other? Like, can one add them, or do we each have to add each other?
You should add each other.
Oh, can I add them?
Wait. Okay. No, sorry. One of you add the other. Yeah. All right, so one of you is... Okay. I'll add you. The other thing is you could give them an expiration date. So I'm going to kick you off the project on Friday.
When you say search for members, are we looking for the @ name?
Yes. So that's just his username. I didn't put the @ I just put his username.
We're using that.
Okay. Can you put no expiration date? Yes. I just chose to, just to show the functionality. Okay. So in your pairs, decide who is person A and who is person B, because that will be relevant later on.
For some reason I'm having, that's okay, you do what you're doing. I'll
You're
come
on register. You're not on sign in.
No, he hasn't
back.
managed to register yet.
No, I registered for GitHub, I think.
Okay, so just sign in with GitHub. You can just click that link.
Okay.
Just say not now, because I don't know.
Yeah.
So if you click that one, oops, looks like you have to verify your email address for GitHub.
So I've got my repository. I was trying to
You go ahead and do that.
Yeah, you're good. Okay, sorry, you're good.
Where are we going after repository?
In
him in?
settings, members. You can also do it that way. It's fine. Yeah, there you go. And then you just add his username, and you can choose your permissions. Okay. Okay. I'll be person A, and you can be person B. Does that sound okay?
Yep.
Okay.
Can you just hit the don't show again on the SAP stuff?
Yes. Okay, you guys are good? Okay. Are you guys in the back? You got the materials and stuff okay? You're getting there? Okay. All right, let me know if you need me to slow down. Okay. Yeah.
I see reporter, developer, master, and
Yeah.
I see collaborator.
No, this is just the collaborator. So I'll say this to the class because it's relevant. Okay, so when you add somebody as a collaborator, I didn't mention this, but you have 4 different levels to choose from: guest, reporter, developer, or master. Again, the terminology in the computer science field is terrible. But basically, this is an admin, so they can do everything they want on the repository. A developer can read and write, but they can't delete the repository. A reporter can read and write. but they can't add people. The developer can also add people, and a guest can just view only. So I added you as a master, and I gave you an expiration date of next week. So you can see he expires in 3 days as a master on the project, but you don't have to give them an expiration date.
Okay, so when we're looking for the person, I typed at in the name and it says no.
You don't do the at, just the name. Okay. Okay, and so everyone also decided who's person A, who's person B? That's decided? Okay.
I'm still not finding it.
So, but I'm at GitHub. The problem is I'm at GitHub. He's at Git Lab.
Yeah, you want to be on Git Lab.
But you changed me over, so I.
No, you had to verify your email.
I did.
Okay.
I did.
So if you go to Git Lab,
Okay, so let's go. Let's get a new thing here so we don't lose this one. Okay.
That would be why I'm not finding because he's not logged in.
yeah, there you go.
Okay. And
You just sign in there.
this one.
Yeah.
This one here.
Nope,
This
just
one.
yeah.
This one.
And then sign in.
This is where you can click your Git.
And then at the very bottom,
Look for the GitHub.
you should see GitHub. And then just give it access. It's just telling it who you are. And now you have a GitLab account
Okay, great.
once you accept. And then you can find him with the same username. Okay. Okay, great. So let's get started in the repository. So there's a few things everyone needs in a repository. Can anyone tell me one of those things? What does every GitLab or GitHub repository have and or need?
A Readme file.
Yes. Did you look ahead? Okay. Well, I guess I gave you the link. Yes, we need a Readme file.
Anna just knew that.
Oh, okay. Well, then props. Sorry. So, okay, a good Readme file. Sorry, I clicked the wrong button. Okay, a good Readme file has a few different things. So a Readme file basically orients people to what's in the repository. So it's a bit like your documentation. There are other people who have a specific Readme file for data, but in general, you should have one Readme file for the project. It has the title and summary, so basically what is this thing, what's it called, who works on it. The authors, so who's responsible. If I have an issue I want to report, if I want to merge some code, if I want to just get in touch with you, who's the person. There are projects who have many maintainers. So for instance, it might live on an organization account, and you need to know who the specific person in the organization is responsible. So always have your authors. You always want a getting started guide. So for instance, if you look at my GitLab repository for these class materials, in my README file, I say to use the stuff in my repository, you need R and RStudio, and you need the following packages. So you can't use anything in my repository without this stuff. And that's a very good point. And this is a big thing for reproducibility. So there's the part of reproducibility that I work on mainly, which is what we call computational reproducibility. Someone gives me a script. I have no idea how to run it because I don't have the right version of Python. I don't have the right version of a software library. My operating system just completely breaks with everything they want me to do. So a good thing when you are getting started is to just say, what are all the dependencies? I need R and RStudio and Bookdown to run this book. The other thing is a license. So you want to tell people exactly how they can reuse your stuff if they can. Say, all copyright is mine. For instance, in this repository, I say it's Creative Commons share alike. So you can use as much of my materials as you want as long as you make it openly available. A contributing guide. So how do you want people to be able to contribute? So I say you can email me. You can make a merge request. I'm open to it. So it's a good way to orient your community. And then a thank you note. So the big thing, sometimes you want to acknowledge who helped you out. So for instance, in this book, my friend Daniel helped me out a lot because I was just getting started with Bookdown when I started making this a while ago. So I would drop him a little thank you note in my README file. So what we're going to do right now is person A, create a README file in the repository using the GitHub interface. You don't have to include all those things, just pick a few. Save the file, and then afterwards, person B make a change. Okay, so that is our challenge, and I'm going to do it with you. For instance, there's this button that says Add Readme, and I'm going to click it. If you go to the repository, so here we are. This is just the repository landing page. They give you a bunch of instructions. It is usually recommended you start with one of these options, such as add a Readme file. So person A, click this just add Readme button, and then we will give it a look. So an MD file is Markdown. So for instance, if I wanted to make a heading, I could just use one hash sign. A super cool project with me and my friend, Scapegoat. Scapegoat 1. And so now I want to save it. You'll notice it's asking me to add a commit message. Does anybody know what a commit message is or why it's useful?
Just a description of what you're doing.
Yes. So for instance, if I was to go to, and I've seen this many times, a random GitHub or Git Lab repository, and I looked through the history, oftentimes it's just a series of messages that say updated, 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 updated. So looking at that history, I have no idea what changed when. So you want to have a very good commit message every single time you change something. It's basically a very short description of what you did. So this is nice because I'm adding a README for the first time, and GitLab is just saying, yeah, you can just add a README. So now when I click the commit changes, which is like a save button, we have a README file in our repository, and I can even tag my friend, Scapegoat 1. And now when I go back to the repository, you don't have to tag, that was just a fun thing. Here, so now that person A, create the README file. When you finish, person B, change it. Add a line, add something else. Okay, so now you change my README file. Do you see the repository?
It's empty.
There you go. Hi, I'm sorry. We're doing a lot of pair exercises for this.
That's okay.
Maybe
Follow along.
once you guys get up to speed.
We're in the free time. We just made it free because we're all back here.
Yeah, right. Okay.
How do you assign someone to be a master developer?
So when you go to add them as a member, so in the repository, there should be a sidebar. So if you scroll down on that sidebar in settings, don't click, hit members. Yep. Then you search for their name.
So he's already added us to his.
Oh, okay.
Can we edit this?
You can't because you're both guests, so he hasn't given you enough permissions.
Can
You can just click this and change it.
Oh, and you can make us a developer.
Or a master, whatever.
Make us a master.
Okay. Okay. Did you change the file?
Just change it in any way.
Yeah, just change it. Add a line, something. Okay. Have you guys changed, person B changed the README file?
Yeah, we switched.
Okay, sweet.
So how do I edit this?
So there's a button that says edit.
Oh, geez.
It's a new interface. And then just add a line and save it. Okay. And then add a descriptive commit message about what you changed.
I did.
Okay, did you change the file? Oh, yes, I'm coming. Okay.
So I've got his file. I
Yeah?
don't know what I moved it over here to here, but so am I, like, where am I making the change at?
It looks. So you went right into the commits, which is a good instinct, but not what we're doing. So if you just click the file on its own, there's an edit button. So just add a line to it, or do something. Click this edit
Oh, there
button.
it is.
Sorry.
No.
And then add a line, make a commit message with something descriptive. Okay, you did it? Cool. Okay.
Oh, she's jumping ahead.
No, I'm not. I'm just showing the change. Okay. So my super cool friend, Scapegoat1, has managed to change the file. Yay. So we have a new line in our file. And now we can look at the commit history. So I can see, how did he change this file? If I click this, I can look at the history. So if you click the Readme file, oops. If you click the Readme file, there's a history button in the top right corner. If you click that, you can see that I added the Readme file, and he showed that he could change it, which is, I'll give it a 7 out of 10 for commit messages. Just kidding. Just kidding. So you can also see on the side, each commit message gets a unique number. This is important because that is the number that is the reference to a snapshot. So for instance, if I wanted to go back to my original file, because I didn't like his change, I could do that by referencing this number. But that's something we're going to do on the terminal. So we don't have to worry about that now. Just know that when we think about how Git stores things, a snapshot of a file and a reference to a file, this is a snapshot of the file, and the commit message over the commit number, the hash, is a reference to the change. So if I want to go back in time, I need to know this number, which is something you can do in Git. You time travel is actually like the community's real way to describe it.
And these are forever, there's no deleting.
There's forever. Well, there are, but not in this class. You can
She's not going to teach you how to describe it.
you can, yeah, there's lots of ways to squash commits is a way to do it. And
Wait,
yeah.
so now that I have a Git Lab profile, like this stupid project will be on there forever?
No, you can delete it,
Oh, okay.
but just don't do it.
Couldn't delete.
Just don't delete it till the end of class. You just can't go back and, yeah.
What am I Git paying?
You can also see all the commits for your project in this commit button on your repository. So if you just want to see generally what's changed, you can click that and it's going to show these 2 commits. Okay, great. So after completing that challenge, you have just used a lot of the key features of version control. You have collaborated with somebody. You have gotten descriptive messages about who did what. These are also time-stamped, so I can double check if I'm out of town and somebody changes a million things while I'm there, I can see, and I can see who did it. And every change you've made has been uniquely identified, so you can try time travel as you want. So basically, we did that. The point I'm trying to make about commit messages and why a good commit message that's concise, descriptive, is we want to avoid this in our history. Just my hands are typing words. Hands, more code. We don't, and the caption, as a project drags on, my Git commit messages get less and less informative. And shameful as it is, I'm definitely guilty of this. But I'm passing it on to you so that you make a note, have good commit messages, so you can tell what you did wrong. And I didn't show you this as well, but in the file, and you don't have to do this, just look. There's also this thing called blame, which is a real thing. There's a command called git blame, which I don't think is very nice, but it's a line by line, shows line by line who changed what. So you can see each of the lines that are in my commit and the lines that are in his commit. So I can see who to blame for the different changes. Okay. Are we good so far? Everyone has done all these things. You feel pretty confident. You can look at your commit history, at least on Git Lab. We're going to do it on our own computers later. All right, so again, one of the things I mentioned at the start of the session is that the reason we use version control is not just for versioning, but that it really makes collaboration easier. And one thing I just wanted to insert into the lesson are 2 ways that are really good to collaborate with folks in the open. So one of those is issues, which is, again, poorly named. Definitely needs some more humanists in the field. So does anyone know what a GitHub or GitLab issue is? They're the same.
They're just errors in codes, like bugs and things not working. Like if you're trying to install something and the required repositories aren't correct, somebody opens up an issue and then the developer can install it.
That's a very good use case of using an issue. People also use issues to just simply, as discussion forums, to say, I want this feature added. What do you think about it? So you see these long discussion chains, and it's one way that people who maybe aren't so technical can still contribute to an open source or an open science, open humanities project. Open research, we'll just call it that, will be the wide branch. So people use labels on issues to discover them.
I was just going to say, I saw a gentleman that made a look-down book. He's published it in GitHub, and he basically encouraged people to leave issues, since he's a native Chinese speaker, to say, hey, correct my English.
Yeah, and exactly that. And I actually, in mine, I taught at a French university, so I said, somebody please translate this into French, and I put it into an issue. So it is a good way to plea for help. And you can do that with issues, with issue labels. So for instance, there's this thing called Hacktoberfest. Has anyone heard about this? Okay, so Hacktoberfest is basically you make 4 pull requests in the month of October and you get a free t-shirt. So it's pretty nice, and it's meant to encourage people to contribute to open projects. So there are a few labels that people use to solicit help. One is simply called help wanted. So these are all of the help wanted things. I want to like comments with an emoji, please help me. I need feedback on this particular feature. And if we click into these, hopefully there's people talking about it. Nope, just one dude, okay. All right, so here's some people talking about it. So this person said, dear developers, thanks for your hard work. This library has really helped me. That's really sweet, okay? Be like this person, say nice things on GitHub issues. After diving into the code, I didn't find a way to reuse this. I really would like to. I would love this feature. So hey, looks like this is the developer saying, yeah, in fact, I tried to add that code here. So you can see people are trying to request new things, give feedback. I would happily accept a pull request. So it's a good way just to encourage collaboration, even amongst folks who aren't so technically savvy. You can at least contribute to a conversation.
Go over what a pull request is.
I will later. In fact, that's next. Forks and merge requests. So yeah, there's also ones called beginner friendly, which I go on all the time, which is like, how do I fix this thing? This is beginner friendly. So people who are new to coding, who just want to get in the field, if you are in neuroscience and you are doing a new thing and you want people to help and it's maybe a good thing for undergrads, you can say beginner friendly. So it's a good way to help out, help people find you to collaborate. Okay. So, however, we have open repositories. All of ours are public. So that means any stranger could come along and ask to make a change to our repository. And there's one way that they can do that, since they're not collaborators of ours, and that is forking and merge requests. So these are people who we don't want to give direct access to a repository. These are people who maybe are on our project, but they would just like some review. So I don't want to change anything until somebody else looks at it. This is another good use case of using a merge request. So a fork is basically a copy of a repository in your own namespace. So what's your username on GitLab?
Me?
Yes.
MLCONTE.
C-O what?
NTE.
Okay. I will just use this one. Right? No, I'll go to the other one. Okay. So I'm not a contributor on this project, but I think I could really improve this README. So I am going to click the fork button. And when I click that, I have an option to either put it on my own profile, or I'm involved in a few organizations. So even if an organization wanted to put some code of their own, but I'm just going to do me. So when I click that, it's literally making a copy of her entire commit history, all of her files, all of her work under my name. So this way I can make changes to it as much as I want, and no one can stop me. And eventually, if I think I have something good and something that should go back in the original repository, I can contribute via a merge request. Does this make sense? So I can do everything here that I can do on my own repository. When I think I have something good, I can contribute that back. So
you're literally just taking the whole project.
Yep. Yep.
So fork is a clone. Taking a copy of it.
No, cloning is different, because cloning is a keyword in Git. So, yeah. Okay, so, yep.
Also assign that project if you're wanting somebody to look over your Readme file.
Yes, you can assign people to look over things.
You do that the same way.
You do that in the merge request. So I can show you when I do this. Okay, so in my narrative, my friend Daniel has this demo, and I fork it, but we know that's not what I did. So then here it is under my name. And what's nice is there is always a link back to the original project. So everyone can always see this is the original code. Okay, so what I want you to do, person B, I know you have access rights, but you can still make a merge request because you want review. So person B, fork my repository, make a change, save it with a good commit message, and then raise your hand to show you finished.
Wait, so fork your repository?
No, like person B, fork person A's repository.
Search for the username like what you did as if they were outside.
Yeah, but you guys know each other's usernames.
Well, right, but
Yeah.
my point is,
Yeah, you
act
could.
as if it's for real.
Sure.
So can you just do that in the search window up above, right in the person's name?
All right. So person B, fork person A's repository. Person B then makes a change and saves it with a commit message. That's all you're doing. We're not doing merge requests yet.
How did you find the user when you were up there?
I just typed in. I asked her what her username is, and I typed it into the browser. So if you go to gitlab.com/, that just searches this project.
Okay.
So if you just go gitlab.com/ his username. Okay.
So we're just forking. We're not
Just forking, no merge requests yet, because we're going to work locally before we do a merge request. All right, you're good? No, you already forked it.
Yes.
Can't fork your own project. Okay, you're good. Make a change to the README. Make another one, and then, yeah. Okay, you guys are good? Okay, sweet. You're okay? Working on it? Yes.
Sorry.
It's all
So
good.
when I try to fork project, I get a weird error message about like the namespace.
Oh, so you already have a project called
Oh,
Utah Project.
Okay.
So
And then-
can you just go to yours and rename it?
yeah. Let's see.
Yeah.
Oh, okay.
Yeah, you can't have
So
the
you
same.
can't have that totally makes sense.
Okay.
Okay.
So I need
Okay.
to go to.
What time is it?
The only option to request it as yourself is you're not part of multiple groups. Like that.
So it's right there.
Okay. So the challenge is person B, fork person A's repository. Person B, make a change to the README file and save it with a good commit message, and that's it.
No, you're in it right now. You forked it, but
And then we're getting into the really time-consuming things when we get to the terminal. Okay. Okay.
Okay, so I've got this forked, and so I just want to open it. Do I open that one?
You just click the file name.
This one?
Mhm.
Okay. And where do I add the commit message?
When you edit, when you add a line,
Okay, yeah.
and then when you save it, it'll ask you for a commit message. So you just
Didn't
add
last
something.
time.
Yeah, so if you scroll down to the very bottom, sorry, of the page,
sorry.
of the web page.
I'm not good on the onboard mouse.
So this is your commit message. So this is what you change when before you click that button. Okay. Yeah, I'm coming. If you have a repository with the same name, you can't fork it. So if you have one called Utah Project and his is called, yeah, so you can just rename it or delete it. It's up to you. Okay. If you want to fork mine, you did? Okay, perfect. Okay, good. Okay. So then person B should have made a change to person A's README file. Yes? And it's been committed? Okay, great. So the next session, we're going to do Git locally. So we're going to take everything we've just done on the GitLab.com interface and bring it to our own computers. And that requires the terminal. So does everyone want a break between now and working on the terminal? All right, it's like 5. We'll come back in 5 minutes. Just walk around, take a break.
So he changed the file. I haven't gotten the merge request.